Stanford University.
This is Joyce Kiefer, and I'm resuming the interview with Anne Kiremidjian. So, Professor Kiremidjian, I wanted to ask you more about your being a grad student, and you're working towards your PhD, and your advisor is Haresh Shah. Now, how would you say Professor Shah was in terms of your being this woman in the department who's very much of a singular person? Was he encouraging? Did he seem to work from a difference between you and male colleagues, or how did that work out?
Well, looking back, I think I was very fortunate that he was very open to having women work with him, and from the very start, he treated me pretty much the same way as he treated all the other students. The expectations were the same, that I would do just as much work as anybody else, and I guess I had demonstrated that I'm capable, and that he took me on. But I have to say I'm quite grateful that he had an open mind, and thinking about the other faculty, if he had not taken me on, I'm not sure I could have worked with anyone else within the department. Maybe, I don't know, but it seemed very natural that I work with him. He, as you know, Haresh, he's a very open and very natural, very warm person, and he was very professional about the whole thing. He said, "Here, I'm one of the students. He's the professor. You're working on a project," and from there on, there weren't any questions. So the issue about the fact that I was the only woman never came up, was never questioned, was never brought up at any particular time. And I felt that I'm doing my work, and as long as I do my work, and things would be fine, and they were. So was he encouraging? He was just as encouraging with me as he was with everybody else. He had high expectations from everyone, and if we had to work through the night to finish a project, that's what we had to do, and it didn't matter whether you were one of the boys or one of the girls, and you had to get things done. You had to get things done. So he was very inspiring in many ways, because he always had a lot of different ideas of what he wanted to do, and he was always such a busy individual, always running around. He always had things going, and what was really nice was that he involved us in just about all his projects. And I have to say, because of him, I did get to travel to so many places, and he opened all these opportunities for all of us, and I was always included. I can't think of, there may have been occasions where he preferred that he takes the boys along, but most of the time I was included in any gatherings that was the thing, any gatherings in his house, I was always included. We were always welcomed. Travels around the world, I was included. So I didn't feel that there was any difference between the way he treated me and he treated some of the other students.
Mm-hmm. And what were the attitudes of the other students towards you? I don't know, I guess I was so focused on what I was doing that I really didn't pay attention to that, I have to say honestly. Mm-hmm. If I think back, I don't know if they had a problem, and frankly, that wasn't my problem. That was their problem if they had a problem. My objective was to get my work done, to excel in what I was doing, and to get my degree and move on with my career and with my life. If they had a problem with that, then
I didn't engage myself in that. It was their problem. I really didn't care. I mean, it's just, and that has been my attitude all along, unless they made it a problem for me. If somebody decided to make it a problem for me, then I would react. But if they had a problem dealing with it, then I just let them resolve it themselves.
So once you got your PhD, did you at that point decide you wanted to continue to teach at a university or go into industry?
I did try working for industry, but in the back of my mind, I had pretty much decided to join a university. Towards the end of my PhD, there were not too many positions available. As it is today, the academic positions are very limited. So I did work for John Blume in San Francisco. I was really privileged actually to work on John Blume, and I was working on a very exciting project. They had just found a brand new fault near the Diablo Canyon nuclear power plant, the Hosgri fault, that was not known to exist when they designed and built the plant originally. So John Blume's company was hired by PG&E to investigate the effects of the Hosgri fault on the Diablo Canyon nuclear power plant, and I was charged with developing a model for earthquakes that may occur on the fault and the estimation of the seismic waves that would arrive at the power plant. So I did develop a model that actually the model was later published in the Structural Engineering Journal with John Blume. It was a very interesting project and a very meaningful project, and I didn't participate in the hearings with NRC, but I heard from other colleagues that they were well accepted. The results that we had generated were well accepted, but it gave me an opportunity to observe Dr. Blume in action, and he was an incredible character, very smart. The gentleman was a real phenomenal brain, very quick wit, quick action. He used to think of answers right away, and he grasped concepts very quickly. I could see him in meetings where people would challenge, and he would challenge back, and in a very calm and deliberate way. And I could only wish I could approach colleagues in the same way that he did, and he was very effective, very, very effective. And we did become good friends, and I'd met John before. Several years before that. It was during the establishment of the John A. Blume Earthquake Engineering Center. He had received all his degrees, his bachelor's, master's, engineer degree, and many years later a PhD from the program in civil engineering and structural engineering at Stanford. So he had a very soft spot in his heart for the civil engineering department and structural engineering at Stanford, and was very excited when Haresh and Jim Geer, Haresh Shah and Jim Geer, decided to establish an earthquake engineering center. And through his general donation, the center was endowed and is still thriving until today. I was still a graduate student. I remember the preparations around the inauguration of the center, and we were preparing all the exhibits and preparing various demonstrations, and I was an integral part of that whole group of people who were intimately involved with all these preparations, and it was an incredible event. It was a very impressive event. They had all the big names from, not just from around the United States, but around the world that came, gave presentations, and participated in the inauguration of the Blume Center. We have pictures, of course, in the Blume Center of the inauguration, but it was a very important event that will stay in my memory.
Do you recall what year that was?
1975.
Okay.
I believe. It was 75, 76, 75. Was the year before I graduated with my PhD.
So then you graduated, you got your PhD, you worked for John Blume in San Francisco, and then at what point did you decide that you wanted to go back?
There were two opportunities for faculty position, one here at Stanford, one at Berkeley, and I interviewed both places and came to Stanford. Berkeley did not make me an offer, I should make that clear. But I'd already decided to come to Stanford and joined the faculty in 1978 and have been on the faculty since then.
So now at the time when you joined the faculty, were there any more women in the faculty in the School of Engineering itself?
Well, there was another lady in transportation engineering who was part of the faculty. She may have come later, Lina Wiggins, and there was a young woman in environmental engineering, Lily Young, who was also part of the faculty in civil engineering, but neither one of them made tenure. And I was the first one to make tenure, go through the tenure process and make tenure.
So do you feel that in that process there were any problems that you had that the men didn't in terms of, extra challenges or?
Well, my biggest challenge was that once we decided to stay in the Bay Area and I joined Stanford, we decided to finally have a family with my husband. That was almost 7 or so years after we had been married, or no, 6 years after we had been married. And it was not until 1980 when I actually was coming up for reappointment, and I decided that, it's not a good time to try anymore. It wasn't even a month after we decided it's not a good time to try that I was pregnant. So the challenge was that I was coming up for reappointment and I was pregnant and dealing with issues of pregnancy and also dealing with teaching classes and doing research and all the things that faculty do. Having a household and so on and so forth. And my husband was working long hours and traveling quite a bit to Washington and back. He had joined a company at that point. He had joined TRW in 1978. And the challenge was acceptance by some of the faculty that I was having a child and that I was actually dedicated to staying on the faculty. I did have some faculty ask whether I'm going to stay home now that I have a child, and I assured them that I am coming back. When it came time for tenure, though, I'd made sure that I dotted all the I's and crossed all the T's and that everything was in perfect order. And I'm told by some of my colleagues that my papers flew through the system without a hitch. That's what I was told. I don't know. I don't know what transpired. I don't know the details, but I know I met all the requirements. I'd made sure I had a discussion at the time with Perry McCarthy was chair of the department, and I remember sitting after my reappointment and going over the points of what it would take to become a tenured professor, tenured associate professor at Stanford, and he explained what the criteria are, and I made sure for the following 3 years too. But it was not easy to raise a child. None of our family was nearby. All of our family is back in New York, and it's hard when you get up in the morning and you have to teach a class at 8 a.m. and there was no excuse just because I had a child, and certainly was expected to teach a class at 8 a.m. I find some of my younger female colleagues expectations from them that they, because they have a child, they cannot teach early classes, and I chuckle and say, "Wow!" I mean, it's really nice if you can get that. All the power to you. But somehow I would not even dare to say that, "Oh, can I have a class later in the day because I'm up all night nursing." And you get up in the morning, you're ready to go to class and teach, and next thing you know, your child is sick. Who do you find? Because she was in daycare from age 7 months on. There were a lot of challenges with raising a child and trying to become a tenured faculty and teaching regular classes. And I had 3 months, not even quite full 3 months. I had the full quarter off. She was born in October 20th, and I came back teaching in January. And also in our field, we travel a lot. We have conferences around the world. So she grew up with mom going here, going there, and we used to joke that she was allergic to the idea of me going to Japan because every time I went to Japan, she got sick.
I see. Psychological, maybe?
Right, yes. And it was not until I took her to Japan with me that she stopped getting sick whenever I went to Japan.
Okay. So did you take her along to very much, or just?
Oh, a lot. She traveled quite a bit because of the trips that we were taking that related either to my work or to my husband's work. And she, as a result, she loves traveling around the world. It's not a big deal for her to hop on the plane and go to London or go to Paris, or because that's what we did. I have a conference halfway around the world. I would hop, and if I could bring her along, I would bring her along. I was known among my colleagues for bringing my child to conferences and bringing her to board meetings and
Great.
Well, I remember until today I was serving on the board of directors of the a group called California Universities for Research in Earthquake Engineering, and I was elected to be on the board. And we had a meeting scheduled for Monday, and I failed to see that particular Monday when the board meeting happened to be teacher conferences when the students got to stay home. Well, what was I supposed to do? Instead of finding someone to take care of her, I said, "Okay, you're coming with me." She must have been 6 years old, 7, something like that, 5, 6, something like that. So I had miles on United, and I got her a free ticket, flew down to LA. The two of us. She was very nice and sat and occupied herself reading and drawing through the meeting. They were all impressed. All my colleagues were impressed as to how well behaved she is. And her reward was that when the meeting finished at 3 o'clock, an hour earlier than it was supposed to, the two of us hopped in the rental car and went to Disneyland.
Wonderful. That's wonderful.
And spend the rest of the day and evening until we could catch the last flight out. And at that time, you could just literally get to the airport 10 minutes before flight and make it without a problem. So we flew back that night, and she still remembers that wonderful experience.
Well, it sounds like you were very creative in working around what would be real huge challenges to people.
Well, sometimes I call them, they were just necessities, and you deal with them as they come along. And that was one way I could deal with them. And she was known to come to the annual meeting of the Earthquake Engineering Research Institute, the ERI, and would run up and down during break and go up to the podium and talk on the microphone because she thought it was so much fun to talk on the microphone. I was recently at the same meeting in San Francisco, and people reminded me, "So how is your little girl?" I said, "Well, my little girl is about this little."
What is Seta doing now?
She is a director at Merrill Lynch at Bank of America in New York City.
Mm.
Right.
Okay, so let's take you back to the Blume Center. I understand that you were co-chairman and then co-director,
Right.
and then eventually director.
Yes.
So, as during your leadership, what were some of the accomplishments that occurred then?
Well, the first challenge was Loma Prieta earthquake.
Oh, okay. So maybe we should talk about the time frame here.
Yes.
Okay, so when you first went to the Blume Center, that was, and I have it.
1990 something, 90.
Yeah, we'll establish that in a minute.
96.
Okay, it looks like you were co-director in 1987 to 94,
Okay.
so that would definitely cover Loma Prieta,
right.
and then actual director in 95 to 2002.
Thank you for refreshing my memory. Right.
So before the earthquake, what kind of research were you doing in there, or what kind of discoveries or that you were working on?
Yeah, as part of my dissertation, I developed the first probabilistic seismic hazard map for California. Up to that point, in fact, when I finished my probabilistic seismic hazard map for California, USGS had developed their deterministic hazard map. And the difference is that when you're doing probabilistic hazard mapping, we include the uncertainty of where the earthquake would occur on the fault, because we don't know ahead of time where it would occur. We include the uncertainty on the size of the event, what magnitude it's going to be, the frequency of occurrences, all of these components, and then we incorporate the contribution of all the faults that might rupture, all the earthquakes on all possible locations. In deterministic hazard mapping, earthquake mapping, is you assume just specific events and you take the contribution of only those specific events. So that's what USGS had done, is to develop a ground motion map of California at the time when I had already developed a probabilistic hazard map. And when I presented it at a seminar in USGS, they were not happy that I was presenting something that was different from what they'd done. I was told that I could go to Las Vegas with my probabilities. Well, ironically, one of the main products of USGS today is to develop probabilistic seismic hazard maps, not just of California, but of the entire United States. And these maps are essential for seismic design everywhere in the United States, and they update those every year. And it took them several years until they actually embraced that technology. And then we started looking at time-dependent occurrences of events, because in these models we assumed that even large events can occur at any time, and we didn't take into consideration the fact that a large earthquake requires considerable amount of time for the energy along the fault to be accumulated to be able to generate a large earthquake. So after the 1906 earthquake, you could not have had another 1906 type earthquake within a day or two. It takes more than 250 years to accumulate the energy to generate a similar size event. It doesn't mean that you cannot have smaller earthquakes in the same location where the 1906 earthquake occurred, but to generate the same size event, you need a certain length of fault and depth of fault and time to accumulate the energy and accumulate the stress along the fault to be able to generate such a large event. And we were not taking that into consideration. So we developed some of the first models that took into consideration the time dependence of earthquake occurrences with one of my very first student, who was also a female. I made sure my very first female student, Talia Nagnos, who is currently a senior provost at San Jose State, by the way.
My alma mater.
Right. So we developed the first time-dependent models for earthquake occurrences. So those were some of the things that I was then involved in some projects with the Applied Technology Council on looking at risk assessment models, where we developed damage functions for different types of structures that enabled you to very rapidly get an estimate of what is the degree of damage if you know something about the shaking of at the site of your building due to an earthquake. So I was always involved with the Blume Center. Harish and Jim Gear were co-directors, and then Helmut and Jim Gear were co-directors. Helmut Krauwinkler, right, who passed away unfortunately a couple of years ago. And then I was asked to, when Jim Gear decided to step aside, I was asked to become the co-director of the Blume Center. And I have to say Helmut in many ways was very open, even though he didn't believe women can be engineers and said so outright.
Okay.
He always came by and discussed any issues and problems and decisions that had to be made around the Blume Center. And we organized our annual meetings or some biannual meetings, and had visitors from around the world. And the Blume Center has always been a focal point for research in earthquake engineering, and as a result, we've had collaborations with Japan, with China, with Europe, and we've had visitors from all over the world all the time until today. But of course, that's made life very exciting, very interesting. In 1989 was the other big challenge.
Yes.
Loma Prieta earthquake. And I was co-director with Helmut, and I was on my way to pick up my daughter Seta from junior high. She was, or was she in 89? She was still in elementary school. So she was 9 years old. She was still in elementary school. And so I was on my way driving on Foothill Expressway. And I'd stopped at El Monte, waiting to make a left turn to go pick her up. And I was on the left turn lane, and then I felt this strong jolt, and I said, "Oh, who hit me from behind?" And I just turned back to see who was behind me, and I saw that there was a gap between my car and the car behind me. There was about a couple of feet. And I said, "This is really strange. Why did my car jump like that?" And as I was thinking, going through that thought process, I felt another jolt, and then I saw the trees start shaking violently, and the light overhanging in the middle of the street started shaking violently. I said, "Whoa, this is a strong wind." Still not realizing that it was an earthquake, I pulled my window down, and there was not even a breeze, and then it finally dawned on me. I said, "Wow, this was a big earthquake." And just as I'm thinking that, there's another aftershock. And at that point, what was really interesting to see was there were 3 rows of cars stopped across from us, and there were the 3 rows of cars on my side. And I could literally see the cars go up and down and across as the wave was coming across. It was absolutely fascinating. Of course, I went, picked up my daughter. Everybody was in panic. She was in tears. The chimney had fallen and just missed the French teacher, much to the disappointment of the students. I was told. Okay. But that was the only damage that the school had. And then I went home. Our china cabinet had fallen down. It's another story. Our china cabinet had fallen down, but it was not attached to the wall, of course. But we didn't really have any other damage, so I picked up my camera and went and started taking pictures of the overpass that's across the street from us under 280. It had significant cracks in the base of the column. And then my husband came home, and I came back to Stanford. We had to regroup, and with Haresh and Helmut and I and Jim Gear, the facilities managers, the architect, the university architect. We had to come up with answers as to, we had to see which buildings were damaged, which buildings were not damaged, and all of us participated in the inspection of buildings the next day and the day after. And at the time, our students had just gone through the training of what we call rapid visual screening. It's a training that the Applied Technology Council at the time, together with the Structural Engineers Association in San Francisco, was offering to train students in inspecting buildings for cracks and other signs of damage, and then rating the level of damage of the structure. And moreover, we had two students in the class that were from the Army. They were both West Point graduates, and they immediately organized all the students.
Wonderful.
There were, Jim Alty and John Luce. I still remember and keep in touch with, at least with John Luce. And they were great. They organized all the students, and their military training came in. It was very obvious. And so all the students were paired with facility representatives, and we all spent the next 2 days going from one building to the next building to the next. We focused first on all the large auditoria. There were people who went to the dormitories, and we had to figure out which buildings were usable, which buildings had to be closed down, then President Don Kennedy was very anxious to be able to tell the students when we can reopen and resume classes. And if you remember, we resumed classes within 2 days after the earthquake, and there were a significant, considerable number of buildings that had to be closed down, like the geology corner, and the museum had to be closed, the church had to be closed, Memorial Church had quite a bit of damage, and I have somewhere pictures in Memorial Church climbing over the parapets and walking over. But it was a very, very interesting experience when we were directly involved in that. And,
did you work with FEMA?
We didn't directly work with FEMA. It was university representatives worked with FEMA, but we worked with the university reps, as I said, with the university architect and facilities managers. I think Harasham may have been involved with the FEMA meetings. I was not. If anybody was, he probably was. But also we were inundated by visitors, by groups trying to come and see what the damage was, because that's what we do. Whenever there's been an earthquake, I went to Guatemala in 1976, and I went to El Salvador in 1983, and I've traveled to earthquakes all over the place, and COPE in 1994, and Armenian 1988, and 89, and so on and so forth. And that's what we do. We go to the earthquake-stricken area, and we look at the damage and try to learn. So people were trying to do the same, and because we had significant amount of damage on campus, all the groups that went to San Francisco, they also wanted to come to Stanford, and a lot of them expected reciprocity because we had gone to see them. And I remember being so exhausted, running from class to a meeting with group from Finland, group from Germany, group from Japan, second group from Japan, third group from Japan, group from China, group from I don't know where, group from Germany, and you name it. And we were giving briefings to all the groups, and we were trying to alternate with Helmut. He would meet with one, but even then it was exhausting. It was really, I don't remember being so tired in my life as I was when we had the Loma Prieta earthquake. But it was shortly after that the chair asked if I would be the sole director of the Blume Center. It was in 1990 or 91, I think, when I became the sole director of the Blume Center.
No, 1995. We could settle this later.
Right.
Okay.
Right. No, it was shortly after the Blume Prieta. It may have been 91 or 92. If I don't have I think 90. Oh, it may have been 95. You may be right, because 95 to 2002. Yeah, probably 95. You may be right. 95. That's actually correct. 95. Right. So, yes, I became the sole director, and the process of rebuilding or re-strengthening the Blume Center had started while Helmut and I were co-directors, but I saw the reconstruction when I was the sole director and had to make a lot of the decisions and work with the redesign of the Blume Center and some of the fundraising that had to take place. And it was very, very rewarding to see the Blume Center reopen. And John Blume had aged quite a bit at that point, and he was fighting Parkinson's, and he didn't want to go anywhere. And one Sunday I convinced his wife, Jean, to bring him over so I could show him what the Blume Center looked like when it was renovated. And he was beaming when he saw what the Blume Center was like after renovation, with the new spaces and areas that have become much more functional, and the office locations and the computer labs, and so the original lab but strengthened and cleaned up and refurbished. And I remember writing a proposal to get funding to replace some of the pumps and actuators on the shake table. So, yes, he was very, very happy. It was probably the last time he came to visit the Blume Center. We had an official reopening, and he could not come, but his wife Jean came, and she was very happy to see what was done.
It seems ironic that the earthquake center would be damaged by an earthquake.
Yes, we had to keep reminding the university that we need to strengthen it soon, because if we have another earthquake, and we were very close to getting severely damaged. If Loma Prieta had lasted, the shaking had lasted longer than the 15 seconds that we experienced, we probably would have seen a lot more damage to the Blume Center.
And the Richter scale on that earthquake was
6.9 on the moment magnitude scale, which is which is the new scale that we use. Okay. Up to about 6.5. The two scales are identical, the Richter and the moment, but the Richter scale has some problems when you get to the high values of 7.5. So 6.9 on the moment magnitude is what we call it now.
Okay. So, meanwhile, let's see, in 1995, you developed a wireless sensor?
Actually, it started in 1991.
Okay.
It was a very interesting development, actually, the way the whole thing came about. It was a couple years after the Loma Prieta earthquake that then Jim Gibbons, Dean of the School of Engineering, held a luncheon for the few women in the School of Engineering, and I remember there were only 6 of us or so. There may have been more, but not everyone can make it to those lunches, as you know. So during that luncheon, I was sitting across the table from a young lady from electrical engineering, Professor Teresa Meng, and of course, the subject of Loma Prieta is very fresh in everybody's mind, and came up, especially when I said I was working in earthquake engineering. And so she proceeded to chastise me. And I said, "What's wrong with you civil engineers and structural engineers? There's so many buildings that people don't know what is the damage and where is the damage. How come you don't know?" And I said, "Well, we probably could know if we had better sensors and more sensors, but we don't." And I explained to her that one of the problems was that The accelerometers that we install on buildings were boxes this big. They were very expensive. They were $15,000, $20,000 each. We're talking 1991 money. And yes, there were maybe about 100 buildings in the Bay Area that were instrumented, maybe. I used to serve on the Strong Motion Instrumentation Committee for the state of California, so we were making those decisions. And to instrument a single building cost $100,000 at the time. So anyway, I was explaining all that to her, what the limitations are. And because they're so expensive, you can put only a few sensors on a building, and when you put only a few sensors, it doesn't give you enough information to be able to say what is the damage, where is the damage, how big is the damage. So we started talking, and she was working on miniature robotic cameras at the time, where the camera can travel around and take pictures. And so we tried to explore that idea. And that would have been helpful, except that most of the damage in buildings is hidden behind walls. And the camera needs light and needs to be able to travel around, and it's not always easy for a little robot to be traveling between the walls where you have all kinds of obstacles along the way. So that idea we scrapped very quickly, but wireless technology was becoming very prominent, and I told her, one of the big problems in addition to being very big, the current sensors require that cables be run up and down the building, and for a new building, it's not as difficult to install cables during construction. But in existing buildings, running cables up and down is a very, very expensive process. So if you spend $100,000 on instrumentation, more than 30% of that money goes to the cabling part. So we said, but if we could do it wirelessly, we eliminate the problem of cabling. So she got very excited, and I got very excited, and we had several meetings. And one of my PhD students at the time, Eric Strasser, got also very excited, and he took the classes from Tom Kenny and Ed Carrier in mechanical engineering. Those were the classes in mechatronics that taught students how to design different gadgets, and they developed prototypes in the class and had them running, and one of the gadgets they designed were wireless sensors. And so of course the biggest problem was getting funding to support this effort, and we wrote one proposal, I believe it was to NASA. It got turned down. We wrote another proposal. It got turned down. And finally, we wrote a proposal to NSF, and it got funded. And so with the funding from NSF, Teresa and Eric and I, with some input also from Tom Kenny and Ed Carrier. Actually, Ed Carrier in particular was working very closely with Eric Strasser, and Teresa was very helpful with the wireless technology. So much so that she started a company on the wireless sensor, the 802.11b, I believe. Wireless chip was developed through her company. I'm pretty sure that's what it was, and it was a new wireless chip that they developed. But anyway, coming back to what we were doing is we designed the very first wireless structural monitoring accelerometer that can be installed in a bridge. We built 5 of those in our lab, and Eric befriended one of the structural engineers at Los Alamos, and actually he's a mechanical engineer but both structural and mechanical engineer at Los Alamos National Labs, who was doing a lot of testing of bridges using conventional accelerometers. So they were very interested in the idea of the wireless accelerometer, and so they decided to do a test on the Alamosa Canyon Bridge, which was given to them. It was a bridge that was decommissioned, basically, but instead of taking it down, Los Alamos was using it for testing. So we took our sensors to the Alamosa Canyon Bridge in New Mexico. And Chuck Farrar and Eric Strasser went to Alamosa Canyon. We had 5 of our sensors. They had, I can't remember, 3 or 4 of theirs. They installed their system with all the cables, and we installed our sensors, and all we had to do is stick them on the bridge itself. I should mention that it took Eric half an hour to put our sensors. It took them 7 or 8 hours to run the cable, check the cables, reinstall the cables, and make sure the system is running. So it was not until the next day they actually did the testing. And the testing involved running a truck across the bridge back and forth several times and taking vibration measurements from the bridge. And we came back and looked at the results from their tests and the results of our tests, and the match was incredibly close. And so we had succeeded in proving that our sensors operate wirelessly, transmit the data. They collect the data. The data is comparable to the data collected by, and actually I can show you this is the very first wireless sensor that we did. I know it looks monstrous in today's standards, but we're talking, this was completed in 94, tested in 95. So at the time, and of course when you do a prototype, you don't worry about size. You try to incorporate as many things. And of course a lot of the chips that you see, many of the combination of chips have now been reduced to a single chip. So you can take this whole assembly and reduce it to something smaller than just this top board. And we have developed sensors now that have the same, actually a lot more functionality than this one had, but it's as big as this top board, basically. But yes, this is my little antique that I keep in my office collecting dust. I see. See, this is like a mother patting its. Yes. So and then actually Stanford applied for a patent, and we do have the patent on wireless structural monitoring instrumentation that we've held for some time now.
So are you able to sell these commercially?
Well, no, because we have not developed a commercial product. We attempted to do it, but I think the civil engineering industry requires a long adoption period, and I don't have the stamina for the long adoption cycle, nor do investors have the taste and the stamina for long adoption cycles. So I'm letting our students and the students of our students develop commercial grade sensors, and they can, and at some point, sometime in the next 20 to 30 years, they will become commonplace.
Okay, so speaking of students, how would you say that your approach to teaching is?
I love my students. My approach to teaching, I'm very traditional, where I do lectures. In the last 10, 15 years, I've been doing a lot more projects. I find that hands-on projects is something that the students really enjoy and embrace. And while it is quite a bit of work in preparing a project, I think they're very well worthwhile. I try to be engaging, and I'm very personable, I think.
Yes, definitely.
I am very open. The students feel free to come and talk to me at any time. I think part of the educational approach. My philosophy is I try to explain the problems in the simplest possible way. Start with the very simple examples and gradually build on examples, the difficulty of examples as we move along. And I try to present one concept at a time and build on the concepts and move from the more elementary material to the more complex and bring everything together at the end. And these projects essentially attempt to integrate the various components of what I've taught them through the class, through a course, and I find that that's been quite effective. But being open for questions, and I always chuckle as to the way some of my professors were, especially early on, very distant and remote and aloof, and I am the professor and you're the student, and I've never believed in that. And I'm very approachable, at least I try to be, and I treat my students as my colleagues, not as someone 10 levels below me. And I do that both with students in class as well as my students that I work with for their PhD, and I treat them as my colleagues. I feel that I learn from them as much as they learn from me. Mm-hmm. And it's always an open dialogue, and doesn't mean I'm not demanding, or I don't have expectations, and I can be unhappy and tell them when I'm unhappy. But I don't think I've ever yelled at my students. I may tell them that I'm not happy and that's a problem, and if there is an issue, I may let them know that there's an issue and that needs to be solved, that needs to be addressed. But overall, I try to have a very amicable relationship, and I keep in touch with practically all of my students. If I don't keep in touch, it's because they're halfway around the world, even those when they are in the Bay Area and they come and visit me. I've been fortunate. I feel so blessed with the students I've had.
Oh, that's wonderful.
They've all contributed to my life, mm-hmm. to my career, mm-hmm. and they've done extremely well themselves.
That's wonderful.
They really, all of my students are doing so well. They're successful and eager and bright, and I just feel so happy to be around them. Mm-hmm. My daughter has a little bit of jealousy, I have to say. She says, "Oh yeah, okay, I know you're with your students again, aren't you? You're happy, aren't you?" Now that I have wonderful time with my daughter. Seta and I have a special relationship as well. I just visited a couple of weeks ago, and we had a wonderful weekend together. But my students are special.
So you've taught undergrads as well as graduates?
I've always had one undergraduate class and two graduate classes, and mm-hmm. and the undergraduates are a different set of students than the graduate students. Our students are so smart, and that's what makes it so much fun to teach. Mm-hmm. And I used to get a little uptight when they would challenge me, and now I chuckle and actually enjoy a little challenge from them. But the undergraduates are very interesting, very smart, and it changes from class to class. But there are some classes that are so enjoyable and so engaged, and we do things that I try to. Sometimes I do a project with them, or at least we have a field trip that they enjoy. It was 4 years ago, we went to see the completion of the deck of the Bay Bridge, and we were the first ones to get on. Members of the building team that were on the deck.
Wow! Oh, that's wonderful. How exciting.
And they were so excited that we went on the deck of the bridge just as it was completed. Mm-hmm. They talked about that for days after that, and said what a phenomenal experience it was. And we were taken on the boat, and we went under. We saw the old bridge. We saw the little condos that they had built for the birds.
Oh my gosh!
They had built the piers, and the cables were down. It was quite exciting. Then 2 years ago, we went to look at the construction of the new hospital, which is an absolutely fascinating project, and they thought that this was incredibly educational for them. So that was a very nice experience, also.
That's the hospital
here on Stanford campus,
right.
The new hospital.
Okay.
Yes.
Yeah. And so you've done undergraduate advising too?
Oh yes, freshman advising for many years. I did freshman advising probably for 8, 9 years, I can't remember. I served on the committee for undergraduate admissions and financial aid for a number of years. I did freshman advising, I've done sophomore advising. I always have several undergraduate advisees. I'm the representative for the civil and environmental engineering minor, so I get a lot of students coming to talk to me about declaring a minor.
Mm-hmm.
Yeah. Well, it's part of everything, the everyday things that we do. I always have to chuckle when people say, "Oh, you teach one class, and you teach 4 hours a week. What do you do with the rest of your time?"
Well, this is what you do, right?
Yes, yes.
And I understand that you had NSF grant, I believe, to advise, so to speak, other women science professors throughout in other universities.
Yes, actually, it was a joint project. The lead is from Drexel University, one of my good friends, who organized most of the women that are in our category, our age group, you may want to say, or our level of our careers. So we had a young woman from Michigan, from Illinois, from Northeastern, where else? I'm probably forgetting. So we wrote a joint proposal to NSF. The professor from Drexel, her name is Aspasia Zerba. She always reminds me how when she had to give her very first presentation at a conference, and everyone else was a man in the room except for me, and I was sitting, and that put her at ease.
Wonderful.
And we've become very good friends since then. But it was she was the one who initiated the program. We received the grant through the education program in NSF to organize a group of earthquake engineering faculty, young earthquake engineering female faculty, where we would serve as their mentors. And it's worked out quite well. So each one of us had one or two women for whom we were responsible. And one of my mentees just received her tenure at Georgia Tech, and the other one just changed school, so it's a little early for her. I don't know, but we met on a regular basis, and it was intended to be a very productive, positive group. And how do we address issues? How do we resolve issues? Rather than, a lot of times women's groups tend to get together and everybody's complaining. And what we said is, we're not going to complain. We're going to think and talk about what should we do to succeed? What are the right steps that women should be taking to succeed? The goal is to succeed, not to complain. The goal is to take the right actions. And that's what I liked about it. Mm-hmm. And I think that's the right way to do it. And it's been really a great experience. And we've had several workshops where we talked about a lot of different issues. How do you manage a personal life and take care of children and take care of what is the process? The same way my husband was very helpful to me with the tenure process. Mm-hmm. Even after I had talked to the chair of the department, Gara was there every step along the way, say, okay, you need to take care of this and you need to take care of. There are certain things that the chair can tell you, but he's not going to tell you all the steps along the way. And my husband, Gara, was very helpful to me. And so we served that purpose. The group is called Enhance. Mm-hmm. I just remember that. The group was called Enhance, and still in existence. It hasn't gone away because all of us are still mentoring the ladies and we're trying to actually grow it internationally. And we went through several discussions of what's the expectation for the tenure process, what is the expectation for promotion past tenure, what are the things that young, and it probably would be helpful for all faculty, not just for women faculty, but our focus was on the young women. It's been a very interesting experience.
Well, that's terrific. So back to civil engineering by that name at Stanford, the name eventually changed to civil and environmental engineering.
Right.
So when they added environmental, why did they add it? And then what impact did that have, or did it on your own coursework?
It had no impact at all.
Okay.
It was really more of a name change. And you said why? If you, well, the environmental problems have been at the focus of our attention for some time now. And a lot of schools were changing their name to be able to draw the attention both of students that we do have a program that focuses on the environment. Mm-hmm. And traditionally the environmental engineering program was the only program that was focusing on the environment. Since then there are several programs. The energy in the environment group is now there, and there's the earth environment and whatever the program is. So those programs have mushroomed and grown, but the original environmental program was part of the civil engineering. We had faculty, Perry McCarthy and a lot of other faculty who, Lynn Hildeman and Jim Leckie and others who are environmental engineers dealing with environmental issues. And so changing the name, well, there was a lot of discussion. Should we or should not? We came to the conclusion that it really won't change anything from the way we're doing things, but it will help recognize the fact that there is a solid, strong environmental group at Stanford, and that students can come to Stanford to study environmental engineering. That was the main reason for the change, but it had no impact on what we were doing.
Mm-hmm. So over time, from the time that you came as a graduate school in the early 70s to now, how would you say that, the culture, attitudes, whatever, have changed within civil and environmental engineering?
Attitude towards women, you mean, or towards students?
Well, I'm going to say women, yes, but also maybe towards students. I mean, in the 70s, great changes took place. This a sense of diversity and having students be more vocal, on and on. And so now all these years have passed by, and I was just wondering how you would compare the culture you walked into versus what's going on right now.
Well, we are in a very unique area, Silicon Valley. And while if you go to electrical engineering and computer science, you would not be surprised to find students who are very entrepreneurially minded. You will find that attitude also in civil and environmental engineering. I see a lot of students taking the entrepreneurial classes and thinking about ways to come up with original ideas to start their own companies. And we saw that also in the early 2000s, late 1990s and early 2000s, during the dot-com era. And there was sort of a lull after the dot bomb of 2002. But we have seen that again. And what also we're seeing is that there is a renaissance of renewal of our infrastructure right now. There's a lot of attention being given to the renewal of infrastructure, to designing structures in a different way, in a more incorporating new materials, new shapes, with the capacity of with the computational capabilities and the memory capacity of computers today. We are able to design some really unique shaped structures, and we are developing new materials, and so we're seeing a renaissance in civil and structural engineering that we had not seen for some time. So I see our field moving in a direction that is very positive and very exciting, and a lot of that excitement is also carrying through our students, or to our students. And it's the same with the environmental engineering. I think the challenge is the attention that is given to preserving our environment with the issues around climate change have had a tremendous impact in what people are doing in our department. I think if I say that there's a change, I think those are the kind of changes that I see. Our students are so much more open to new ideas. And if I think back of the students who were here when I came, and the first set of students that I was teaching, they were much more traditional structural engineers. They just wanted to learn the methods, and they just wanted to go out and design the way things were accepted. And I think the new structural engineer it certainly challenges some of the ideas of the past. I think we're seeing much more interesting concepts being implemented. Some of the new transportation ideas that are coming around, because we have to address those challenges with overpopulation and concentration of populations in very close areas. I'm sorry. We've seen the population explosion of the Bay Area, which is creating a tremendous traffic problem and housing problem and all kinds of other problems. To a great extent, it falls on the civil engineering profession to address these problems. So we are trying to look at solutions. We have to come up with creative new solutions. We cannot rely on the solutions of 10, 20, 50, 100 years ago. We have to come up with new solutions, because these are new problems that have not been addressed before. And I think that in some ways I envy young people, because there's so many new opportunities to be creative and to come up with unique solutions to the problems.
Okay, so just in kind of summarizing things, I'm going to ask you a couple of things about Stanford in general, and one would be, what would you say, name me one of the most memorable experiences you've had here?
Oh gosh, there's so many. Most memorable experiences.
Oh, just one.
Getting my tenure.
Okay, sounds great.
I think that was probably one of the high points of my career. Was getting tenure was like really a stamp of approval or achievement that I felt, being the first woman to actually go through the tenure process and getting tenure at Stanford. Just working with wonderful colleagues and working with great students. If there's, I can't think of any other single event that has. There are just so many events that have. There are things that happen all the time, and that I've been part of, and I feel fortunate to have been part of the initiation of the Blume Center and the growth of the Blume Center, and bringing it to a point where it has become a world-renowned institution. I just feel incredibly fortunate to have been part of that entire process.
So, can you name me a person or two who you think has been key in your in your career and making you who you are? That is just a memorable person or persons in your life.
I probably would name several.
Okay.
Starting with Harash Shah. Another person who made a tremendous impact and influence, had enormous influence on me, was John Blume. A third person who I had the fortune to work with was Emilio Rosenbluth, who is a very big figure in earthquake engineering. He was at the University of Mexico. I had a joint project with him after the 1985 earthquake in Mexico, off the coast of Mexico. A very big name in our field. He also had a tremendous influence on on my research. And I'm sure there were so many other people that I had worked with over the years. And the last person that I would mention is my husband, Garo. He had a tremendous, tremendous influence on. It was his encouragement through all these years. He was always there for me. Mm-hmm. I don't think I could have done that without him.
That's wonderful. So I know that you've received numerous awards, but I was wondering, I know they're all meaningful, but which ones come to mind as being the most special, the most meaningful to you?
I'll start backwards.
Okay.
Being elected distinguished member of the American Society of Civil Engineers, I thought was a tremendous recognition. Mind you, I'm only the fourth woman of the 100 and some years history of the society to be given the distinction. There were only 3 other women before me who had been elected distinguished members over the 100 or so years of history of the society, more than 130 years, I think, since the founding of the American Society of Civil Engineers. So I thought wonderful. That was a tremendous recognition. There were 2 of us that year that were elected, so we were 4 and 5. So you can say I was 4, she was 5. Well, it doesn't matter.
Okay.
We were 4 and 5. And I felt that it is a unique recognition, and I thought that was I really cherished that. Some of the others were being given the C. Martin Duke Award by the American Society of Civil Engineers for research in lifeline earthquake engineering is also very special. I thought that was very, very special, and I can't remember some of the others. I'm sorry. Well, I don't dwell on what I've been given. So,
well, it was just it wasn't to denigrate any of them, but just to what would come to mind right away. Mm-hmm. And then I'd also just like to ask. Okay, so have you ever been back to Bulgaria?
Twice. The first time was in 1972 during our honeymoon in Europe. We decided to hop back in Bulgaria. Bulgaria was still under communism in '72, and it was probably the most negative experience that we had anywhere in the world because we were followed everywhere. They opened our luggage and exposed all the film that we had taken for the month before that in Europe, and we had the same guy follow us from Sofia all the way to the Black Sea, and we would go to dinner. He would be sitting across. We would be in the middle of a small resort town. He would be following us, and also it just was our relatives were very nervous to see us. And if I tell you that we found out after we left and we came back, and the very last night before we left, we had dinner with all our relatives at a restaurant in Sofia, and I danced with my uncle, and when we came back we found out that he'd been fired from his job because he danced with me. My cousins were petrified to be seen in public with us because we were coming from the United States. And I had vowed, when we landed in Vienna after living in Bulgaria, I vowed that I will never, ever, ever go back. Mm-hmm. And when communism came down in '89, Bulgaria also became whatever you want to call it, this so-called semi-democracy. It's still a semi-democracy, I would say. My husband went back because his family had a lot of property that was confiscated, and he went back several times actually to try to retrieve the property that his family had, and he kept telling me that, oh, things have changed, we should go, and I kept saying no, and then finally it was not until our daughter Seta really wanted to go, and he said, oh, okay, I'll go. But I was very pleasantly surprised, and I have to say it had changed so much. Growing up, I remember that my parents saying Bulgaria was the breadbasket and the agricultural center of that whole region, and there was never any shortage of any food. But when I was growing up, everything that was grown in Bulgaria went to the Soviet Union, and there was very little left for the people in Bulgaria. And one week there won't be potatoes, the next week there won't be onions. And I remember the whole family lining up and waiting in line to get one egg each. And my parents were just appalled. They said, what happened? Where is all that food going? And because, we would see on in the movies how the agricultural co-ops would be producing and cultivating acres and acres with food, but it all went to Russia. So when we went back in '72, the plenty agricultural products, were just enormous. Just the plenty was so obvious, and the quality was phenomenal, and the food was wonderful. People were so happy. It was wonderful to see how happy everybody was, and there was definitely air of excitement that was surrounded everyone, and it was a wonderful experience. And I haven't been back since, but I guess I'm afraid that I may not have that same great experience. But a lot of our friends, my cousins still live in Bulgaria, and say, oh, you should come. I'm sure we will.
But that was what year, that last visit?
2002.
2002. Oh, okay.
Yeah, 2002.
So, what else would you like to do if you ever retire from Stanford and you have more time?
Well, I'll probably do some writing. I have been hoping to write a book, which I have the initial chapters, but I probably will do that.
And this would be
on earthquake hazard and risk assessment, and what we now call performance-based engineering. This is one of the classes that I teach. I'm done consulting. I don't do consulting anymore. Yes, I'd like to go back to playing piano. I haven't touched a piano in about 30 years, which is going to be a challenge in itself. I started playing tennis. I'm just learning, and it's really challenging, and I keep telling all my friends that it's very hard to teach an old dog new tricks. So it's really challenging, but it gets me out and gets me with people, and I'm actually really enjoying it. I'm having fun. I'm terrible at it, but I'm having fun. I end up laughing a lot because I miss so many balls.
The balls are small, aren't they?
Right. They get smaller somehow as you get older. I'd like to do some painting. We've done so much traveling with my husband that we seem to, a lot of people say, oh yeah, we'll start traveling once we're retired, and we've traveled in so many places, but we like to go back to the places that we like the most. But I personally also have a long list of places that I would like to visit that my husband, Gara, doesn't like to go. Some of the places that I'd like to go are, like to go to Vietnam and Cambodia and Indonesia, South Africa and Zimbabwe, some of these African countries that I've never been to. there are several countries in South America that I'd like to visit, like Chile and Peru and Argentina. But I'm scheduled to go to Chile and Peru next year. We'll see if it happens.
Oh.
There's a conference in Chile, so I'm hoping to take advantage of that. Yes, so I may figure out a way to get to those places. But we do like to go back and some of the other places that we would like to travel more is within the United States. There are so many places that we have not seen in the United States that we sit back and say, oh, we've been everywhere else in the world, but in so many places, we're just about all of Europe, but we still don't know all of the United States. So there's so many places that we would like to go within the United States. So
On a road trip?
on a road trip.
That's the only way.
Yep, on a road trip, yes. Stop and explore and visit some of the national parks and some of the great cities. And I mean, we've been to many, we've been to Boston, New York, Washington, Seattle, and Atlanta, and a few other places, but New Orleans. But there are a lot of other cities that we would like to visit and find out more about the people and things that are done.
So is there anything else that you'd like to mention before we close?
Well, all I can say is that this has been a tremendous ride. I've been at Stanford 44 years, and I wouldn't change anything. It's, I think it's a great place. I love when my classes are in the main quad. I've been here 44 years, but every time I walk into the main quad, I take a deep breath and take in the view and the beauty of the campus.
Wonderful. Well, I want to thank you so much for taking the time to do this interview. It's been fascinating.